So this article is related to automated particle detection using the image processing watershed transform system. In this article, basically, I have present the approach to particle detection in the images using the image processing techniques and watershed transform. Basically, I have proposed the gradient calculation with the thresholding, morphological operations, and watershed transform to detect and separate the particles in MATLAB. Okay, so in the algorithm is implemented using the MATLAB and demonstrates the promising results of in detecting the particles in various images. Okay, so I have added the keywords introduction with the like how I have just added the detection and analysis of particles in images has become according to the medical like a crucial task in various fields including the medical research, quality control, and scientific investigation. So yes, thresholding. Okay, so the thresholding basically was performed using the OTSU methods, which is basically morphological operations were applied based on the principal outline. Okay, so in the introduction, I have added the HSV based image segmentation, which is basically the true approach. Okay. So the article basically presents how the automated approach to particle detection using the image processing and watershed transform highlighted the theoretical background, implementation details, and the experimental results for the proposed method. Okay, so in the basically just a second. The aim of research is that we need to detect the article and we need to demonstrate its effectiveness of the proposed approach in detecting of particle in various images. Basically, we are just dealing with different images in the MATLAB and we have added that as an input images in the MATLAB and then we just detect the particle according to the algorithm implemented in the MATLAB. So these are the particle detection image, which is basically as an input image we just added in the MATLAB. So basically, we are just detecting according to the using of canny edge detection algorithm. Okay, so the canny edge algorithm basically detects the article, detects the different operations in terms of particle detection and it detects the defects and the contaminants. Okay, the challenges, I have added the challenges with the need of automated particle detection, then image processing techniques for the particle detection system and the proposed method. Objective and scopes are added, problem statement is added, the methodology is added. Basically in the methodology I have added different like how we can just add the image acquisition through digital camera or imaging device, then pre-processing, then gradient calculation, thresholding, as well as a watershed transform, particle detection, and the post-processing. Tools and techniques, these are the tools and techniques used, like in our case MATLAB is a tool and technique tools used, and techniques such as filtering, thresholding, morphological, and the pre-process and analyzed images. Performance evaluation, basically these are the workflow for the particle detection and the convolution. So yes, designed MATLAB simulation and analysis, which is basically I have added the complete vision of the gradient pre-processing techniques used in the MATLAB. like how we can use a computational approach to vision and image processing in terms of work of Mar. Where basically that Mar is the scientist who just performed that images particle detection technique using the filtering and thresholding according to the image processing in the MATLAB. Okay, so see, these are the image input image, which is original image, and then this is the I have just generated the convert into particle detection technique, and then it detects the object 1 and object 2 according to the technique. Okay, see, it just hides the first object which is overlap with the second object, so it just removes the first object's place in detection of second object. Okay, so the original image containing the particles to be detected, how HSV images perform during the color space. Hue channel is used to detect the image according to color tone information. Saturation channel image and the value channel. Okay, so hue gradient magnitude and threshold images, saturation gradient magnitude and thresholding images, value gradient magnitude and threshold images, okay, and recombined threshold images. These are the output results for the MATLAB image after the noise removal and the distance transform according to image after watershed transform. So basically I have detected the complete MATLAB output results according to the particles and the threshold images. Okay, then conclusion and references are added. Let me just show you how these are the MATLAB code we have just implemented. Okay, CLC closure. Okay, we just need to run this automated vertical detection images. Okay, see, these are the output results according to image detection techniques. Total basically 13 figures. See, it is the number of particles 61, image after threshold transform, performance transform, distance transform, image after noise removal, recombined threshold images, basically value gradient magnitude and threshold images, saturation gradient magnitude and threshold images, hue gradient threshold magnitude and threshold images. There is your value channel, saturation channel, hue channel, HSV images, and the original image according to the object 1 and object 2 detected. Okay, so these are the output results. If you need to ask anything, you just call me. I will answer your questions. Thank you.